Something seems a little wrong with the stream here, so I gotta figure out what's going on. Looks like let me double check this. Yeah, what's going on there? Okay. Yeah, is the resolution looking good for everybody? I think it's finally cleaning up a little bit. Hey, Mort, it's good to see you. Okay. We've been getting some rain in Austin. Eric, where are you getting that rain? Pennsylvania, that makes sense. The hurricane end up hitting y'all at all? Well, so today's going to be pretty casual. I'm just going to do some work on Beaker. I've been porting Beaker to Electron 3, which is a good thing to do because that bumps the version of Chrome that we're using internally from Chrome 61 to Chrome 66, which is good for staying up to pace with security patches as well as new browser features. Maybe the best one's going to be getting top level await in the dev tools. That'll be really nice. But there are a couple of breaking changes to Electron that I'm having to sort of update here. And I'm pretty deep into this now. Managed to get maybe half the tests passing, and what I'm looking at right now is the experimental tests just hang. So I'm going to do a little debugging of that. So you're going to get to see kind of what I do for my daily workflow working on Electron and Beaker. If I wrap this up quickly, I might switch over to some of the work I've got going, re-enabling the process level sandbox. Chrome has a sandboxing technique that I believe every tab, sometimes the tabs get grouped together, they have different strategies, but the idea is that the tabs are put into a sandbox which is enforced by the operating system. Normally you would want that, it's a good thing. Electron by default disables that process level sandbox, which is not great for security, so we have had to go without it for a while. but the tooling inside of Electron has gotten better around sandboxing, especially with Electron 3. So I've been experimenting with another branch in addition to updating to Electron 3. I've been experimenting with getting the sandboxing re-enabled. So I may switch over to that. But first up, I gotta figure out what's wrong with these tests and try to get some of them going. So while I'm doing this, feel free to ask any questions you have about Beaker or DAT or anything related to it. I'll be watching the chat and answering any questions. And I'll go ahead and say it's in the chat for anybody that shows up late. Okay, so let's get going. I'm just going to say what I'm thinking as I work. Hopefully that'll make this interesting. So where I left off, I had found that these experimental API web tests were failing. In particular, they're just stalling during the initialization. They're not even getting to the point that they run a test. And so we've probably got some kind of syncing mechanism, something that maybe like waits for a promise to resolve that's just not ever getting hit. So first thing I'm going to do is confirm that still happens, and it does. Okay. So we need to jump into the test here, start sticking some console.logs in there, find out where it stops making progress. Couple of other bugs that we've got with Electron 3. We don't have yet native sodium builds for Electron 3. Plus, you may have noticed the traffic lights aren't rendering. That's an Electron bug that'll hopefully get they got a fix for it. Hopefully, they'll release that soon. All right. So let's jump over to the test that I'm trying to run. This is the experimental capture page. And let's just go to the first test and see where things stop making progress. People say this all the time. It's true. Console.log continues to be the best way to do quick and dirty debugging. Because it's such an easy way to find out where your code path ends up getting jammed up or dump out values. So let's find out where the code path stops. Okay, we got to 0 and stopped there. That tells us that running experimental.capture page doesn't even... It's interesting. So it doesn't ever respond. Why might that be? I'm going to run it again, and I'm going to open up the dev tools of the active process and see maybe if any errors showed up inside of there. The way that the test runner works, it's actually a custom test runner that I wrote at one point. It uses stdio to have the test runner communicate with the Electron process. And so the test runner communicates with what's called a test driver inside of Beaker through sending messages on stdio back and forth, which is actually easy to do in Node.js. They have built-in tools for that. Interesting. There it goes. And so I basically send commands to, nothing there. I send commands to the Beaker process saying things like, please run this JavaScript inside of one of the tabs. And then it'll execute the JavaScript and report the results back. So that's what we're trying to accomplish right here with this. We've captured the reference to the tab and asking it, okay, execute this JavaScript for me. And it should be trying to use the API that we're trying to test. And it actually should fail. what it shouldn't do is just not respond. So let's get a little more specific with our logging here. Let's see, I mean, I'm pretty sure that it's just getting stalled here. It's not returning anything at all. But just to make sure, this would be surprising if we learned anything new. What I'm probably going to need to do is start to instrument the function call itself. So I need to find out, is capture page getting hit internally? If it is, does that execution respond? What could it possibly be waiting on? So basically, I just need to start dumping those console.logs inside the internal code. Yeah, okay. So we're getting stalled on capture page. So let's jump into Beaker core. Actually, first Beaker is split into two different pieces actually right now. The Beaker core module factored out a lot of the reusable logic inside of Beaker into an independent module, an independent repo called the Beaker core. The reason for that is that we may end up wanting to reuse that logic in the future to build extensions or things like that. So I need to make sure that I'm linked to my development version of it. Okay. That's done. Let's go over to the capture page API. Let's find out if capture page is even getting hit. And since these test runs take a little time, let's just throw some logs inside of it to possibly give us some more information if it gets further than I expect it to. One of the nice things I managed to get going in this test runner is that the console.log for almost every part of the execution environment gets dumped into the console. Okay, interesting. We didn't see anything for the experimental method call. Why might that be? Let's try this. It's really strange that this would just delay and not hit the method. Let's make sure that my dev version is getting used whenever it starts. So if that doesn't dump out into the console here, I'll know that I'm not seeing results from the dev version. Yeah, we are using the dev version. There it is, right there. Okay, so the fact that that output tells us that we are running this code that I'm modifying, but for some reason capture page didn't even get called. Okay, interesting. Let's remove that. This gets me pretty immediately thinking that we may have a problem with the RPC. So the first thing I'm going to do is take a look at this code and see if maybe there's anything in here that could be causing an error. Okay, so what we're looking at here is with Beaker, we inject some new web APIs into the page. And the way we do that is through something called the Preload Script. It's a script that gets executed prior to the page loading. And a lot of what it's designed to do is actually set up JavaScript functions which will make RPC calls to Beaker's background process. And so that's reflected, and we grab these manifests for the different RPC protocols and then we use the RPC toolset to create the connection sort of to the back end. So, what we're looking at here is the experimental APIs. These are the ones that we're putting in more or less temporarily as a kind of trying things out. So we import the API, and that gets attached to this object, and then that gets put onto something that kind of cleans up the interface even more. For instance, the library API has mechanisms for event streams. And so we have some interfaces for handling that. So what this has me wondering is there possibly an error occurring in the setup of these APIs here? And a good way to find out is to stick some console.logs in here to find out if maybe it's not getting all the way to the end. And if it capture page is the API, so we should see these, if I remember correctly, we should see those console.logs show up inside of the DevTools for the page that the test is running inside of. I hope. William asks, what's the best way to start hacking on DAT? Well, it depends on what you want to do, William. If you want to make web apps that are built on DAT, that's one direction. If you want to work on like back-end services or like web services that integrate DAT in some way, you know, that's a different direction. So give me a little bit more about what you're interested in doing, and I can answer in better detail. Okay, so let's look in the console here. Nothing here. Nothing here. Experimental is defined. I may need to run a build step. That might be what that is. Yeah, that is what that is. The options passed in said timeout false. What are you referring to, Eric? So William says he wants to learn how DAT works under the hood. If you go to this website here, you'll find some resources on how DAT works. In particular, look at the DEPs page. DEPs are formal specifications. So start by reading the hypercore one, which is DEP2, and then you may want to move on to DEP4, which is HyperDB, and then you could also find some more with there's a link at the bottom of the DEPs page to pre-draft DEPs. These are DEPs we haven't finished yet, where we describe in those some amount of the wire protocol and peer discovery and some more of the data structures. So all of these DEPs are works in progress. But that's a good place to start. And I know that some work is being done in the near future to make more approachable guides, but that's, for the moment, you have to look at the specs. Another place to check out would just be some of the code repositories. I'm sorry, I'm pulling up the URLs here. So HyperCore is one of the main internal pieces of DAT, and it's a great place to start poking at that. And then HyperDrive is another good one to look at. hyperdrive is built on top of hypercore. And so if you start poking around in that code and looking at those DEPs, you should start to get an understanding of how it works. Again, I'm sorry, it's all, yeah, the code is difficult. I would say take a look at the DEPs, and the nonprofit that helps maintain that is putting together funding right now, has gotten funding recently to work on more documentation. So hopefully we're going to be seeing better internal documentation soon, guides on how that works. Okay, Eric, yeah, that makes sense, actually, the call to the RPC having a timeout, having no timeout on it. Yeah, I mean, that would makes sense. It would cause the timeout to occur, but we shouldn't be hitting any kind of timeout condition here. All that would do is cause the calls to eventually error out with a timeout, which is not the behavior that I wanted to have. I need to figure out what the root cause of this call not returning is. So let's get back to the debugging. Let's take a look in the dev tools and see if those messages that I put into the experimental area showed up. They did. Okay, and they got all the way to the end. Let's see what happens if I call that method directly instead of having it run in the test. If I just call it right now. It did what it's supposed to do. It failed. Interesting. Okay. So let's try sticking a console.log inside of this execute. These methods have an unusual way of working. Whatever the last expression is inside of the code block that we run ends up getting returned. So it's almost like we're doing this, but we're not. I wonder if I can actually. There may not be a top level await, so let me rewrite this. Here's how I'm going to do this. That'll have the effect we want. Okay. Let's find out if that shows up in the dev tools. It didn't. That didn't show up in the dev tools. This makes me think that maybe the test runner is broken. Okay. Well, so I guess what I'll do now is instrument the test runner. So we get to take a look at that. In the background process of Beaker, there's the test driver. And this is what handles messages that are sent to it through stdio by the test runner. So this message will show up and it gets mapped to these methods over here, so it's kind of a little informal RPC system I put together on there. So execute JavaScript on page is what should be getting called. So let's make sure that's getting called. And then, let's see. Should see something there. Let's build just in case. Yeah, I think I do need to build. For anybody curious, my computer usually doesn't run this slowly. The streaming software kind of steals a few cycles here, so it's usually not this bad. Yeah, about 25 to 30% of my CPU is used up by the streaming alone. Okay. Let's try it again. So it is attempting. It is attempting to run it. Doesn't seem to be working out. Well, so then I have to wonder, maybe the page isn't set up in time, so maybe it's trying to make this execute call prematurely. It's always a possibility. Okay, let me get some music going for myself real fast. Nope, my Apple Music is not syncing up my playlists. Alright, let's find out why that execute is not working. The first thing I'm going to do is add another call, one that should be less controversial, right? One that doesn't test anything, just a console.log. Okay, so we'll see if that runs. And then inside the test driver, I guess I could look into well, let's try running that real fast. It's true, Eric. I'm locked into Apple Music, and they got me good. That didn't run either. So this is interesting. This didn't get called either. So that's telling me pretty clearly that my code to execute JavaScript is not working correctly. Huh. I wonder if the API for executing JavaScript got changed on me. It's possible. I feel like it's either going to be that, or maybe whatever condition I was using to watch to say if the page is ready for something like that. Maybe something subtly changed there, and these JavaScript calls are getting sent before the page is fully constructed. That's a very real possibility too. This method right here should be saving me from that possibility. So I have two places to look. One is, did the JavaScript execution API change? And the other is, did the APIs around page readiness change? Both are really possible. And also, both are kind of a pain to test. Okay, let me think. Navigate to. Did stop loading. I think did stop loading got removed. Did it? Actually, that may not be true. Just wish it was true. Yeah, no, it couldn't have been removed because otherwise it would never resolve. Let's check if... Yeah, I don't know if they didn't change their event model. I mean, they changed some events, but it wasn't a huge set of differences. Let me just double check also that I'm not getting any errors in the dev tools, or in the shell window, that is. No. Okay, let's take a look at the execute JavaScript method. Right here. Execute JavaScript. Data changed. So I'm looking at the API documentation for execute JavaScript. Looks fine. You know, one way we could test if the problem is that the page isn't ready yet is we could just stick a delay in there, like sleep for a second, and if it starts working then, it's a pretty good indication that it's because the page isn't ready. So let's do this. This will add a 1 second sleep into the test execution. And if this solves it, we definitely know what the problem is. Best way to fix any bug is just to stick some random sleeps inside of the code. Fixes every bug. I fixed it. Yeah, okay. We figured it out. Awesome. The problem is that whatever code we have that is waiting for confirmation that the page is ready to have code executed, it's running prematurely. So I need to find whatever I should be waiting for and wait for that instead of what I'm doing now. But first let's clean up all these random logs because now we just don't need all of them. So all that can go. And all that can go. Okay, so now we need to figure out why navigate to, what it needs to be waiting for. Did stop loading is too soon. Let's take a look and see if there are any better methods to use. I have to betray the fact that I'm using Chrome right now because I can't open Beaker while I'm doing this dev work. Okay. Oh, thanks a lot. What do y'all think of this new UI in Chrome? Up on the top here? Thumbs down, thumbs up. How do we feel about that? tell you, I can say for sure that if I turn on the bookmarks bar, oof, look at this. You lose all sort of differentiation over there. So I had to turn off my bookmarks bar so that I could just tolerate even looking at it. It's okay if you don't have the bookmarks bar, in my opinion, but only just okay. Don't love it. Okay. Did stop loading is what I was looking at, and that was on the web view element. So let's take a quick look at the web view element API. It's possible that they deprecated that event, but that wouldn't make sense because it is resolving. So the event is getting called. Did stop loading. It's still there. Yeah, maybe I just need to change it from did stop loading to DOM ready. That seems like a pretty sensible event. So let's try that. Okay, and I need to build it. Eric asks, will I be able to test that identity with Fritter? No reason that Fritter shouldn't be compatible with the identity spec. The identity spec is really lightweight. Yeah. But I am kind of planning to move away from Fritter a little bit. Because one of the things that needs to happen next is the sort of tooling around data from multiple applications needs to mature a little bit. And there are just a couple of choices with Fritter that I want to move away from. But we'll see. Fritter has been great for learning a couple of things off of, like how to build something like Fritter. It was really good for that. Okay, haha, we've done it. Bug fixed. So that's all that was. My test runner got totally hosed by a subtle change in the Electron code, and I had to track that one down. That was an adventure. So let's just try running all the experimental tests and see if they all work. Anyway, the identity spec has gotten good feedback, which is I'm really glad to hear, because people can be really, as they should be, really opinionated about these kind of things. But for the most part, the response is positive. The question that is still hard to answer, I think, is how we're going to do data management between applications. It's easy if you sandbox the applications. So we could do a thing where every app is, every website that signs into a data identity gets a folder. Like for instance, if you're at fritter.hashbase.io, we could automatically create, when you sign in, a /apps/fritter.hashbase.io, right? A folder specifically for that domain, and you could read and write inside of there, which is great, really clean and obvious, and it has a nice single origin policy sort of design to it. Problem is that it kills one of the things we want to do, which is we want to be able to have applications sharing data between each other and potentially changing each other's data. And so if you start segmenting by origin like that, you kind of set things off on a foot where applications are hard to move away from. For instance, if you wanted to fork Fritter and make your own version, you now have to somehow get your fork to be using the folder that Fritter was using. So I think it would be actually smart not to do that, as obvious as it might seem. And instead, we ought to be thinking about a mechanism where apps are very explicit about which folders they want to read and write. which kind of sucks because then the user has to say yes to letting them read or write a specific folder, and there's not a lot of information for them to go off of on those sorts of decisions. For instance, say Fritter uses /apps/social. The user, if they're not the ones creating the files inside of the social folder, they don't know if that folder even exists. But now Fritter is asserting that it does exist and it would like to read and write it. And I'm just going to have to kind of be like, yeah, sure, I guess. So that all sort of speaks to the fact that we don't have a lot of semantic knowledge from the perspective of the browser about what the data is inside of those files. So an obvious thing to do next is to say, well, you know, get some links in there. Right, how about the app just using pointers to the data? Exactly. Get some links in there and have those links, you know, provide metadata that explains what the data is, and then construct permissions around that. Sounds great to me. But it's just sophisticated enough, just complicated enough for me to not totally know what the right calls are. And I've been messing with this for a while, and I just have a lot of open questions still. So that's really where the hard work remains right now. So for this V1, I kind of think we're just going to go with an unideal solution that's as unopinionated as possible, and then do a little bit more work inside of user land, just trying things out. And then we'll re-examine this question about data permissioning, sharing data between applications, and see if we can improve on the situation. 16 passed tests. That is good news. I think that means that all tests are now passing on Mac OS. Let's see if we can get through all the tests without crashing, because the test runner has a habit of crashing if I run them all together. I usually have to run them individually. But I kind of, you know, hey, maybe Electron 3 finally has solved that. So let's give it a shot. Eric's pointing out that Peter added a type on top of documents, but the type definitions can change in the future, so you need the version of the types. Yeah, I have no question that like some kind of types information is going to end up factoring into this. If you use links, links have historically had a type information with the rel attribute, which stands for relation. So you can sneak type information in there. Also, Beaker has been using a type field on the dat.json, so actually dats can be typed. There's just a lot of questions that come up after you say, okay, let's use types. It's like, okay, well, how did the types get managed? How do we know what they mean? You basically get into a situation with this where you need a way to enforce permissions on data, and you need to be able to describe the data. And now you're in a generic data description framework, which is a whole lot of work. Can easily balloon into a giant spec of descriptions of data. And I suppose that's what the whole RDF world is, resource description framework. But I'm trying to split down the middle, find something that is really convenient for developers but gets good results for users, and it's going to take a little work. I think we can get there. I'm just going to have to take our time. Okay, so apparently my test Beaker instances don't like to get closed after the tests have finished. Not sure what that's about. But it's not crashing, which is a step up, I suppose. I wonder how long until my computer starts to run out of resources here. It's not crashing. That is an improvement. That's going to be a failed test. Oh, that is so not helpful. I guess those are the kind of bugs you get when you build your own test runner. Suddenly it stalls out, and now you don't get any information about how the tests failed. So now I get to run them all manually again. That's fun. But once all these tests clear, I guess that gives me a chance to go and check my to-do list here. Come on. Stealing focus is rude. Okay. You need to go. Yeah, this is one to fix next. So I'll describe this one while we're waiting for the test to run. For some reason, the dev tools are not accepting command shortcuts. I can't Control V or Control C inside of DevTools. Cannot have that. It's a major pain to not be able to use copy and paste by the keyboard in the DevTools. I gotta diagnose that one. That may just end up being a Electron bug. So I'll have to start by looking inside of the Electron issue tracker, see if anybody's filed anything related to it. If not, I get to start debugging it myself. It is a very common flow for working on Beaker. Step 1, check the Electron bug reports. This should be the last test I need to run. I think actually this one already ran correctly, so. Boy. Wrap it up, come on. Alright, I'm declaring victory and moving on. Okay, let's start checking into this keyboard shortcut issue. So let's start by taking a look at an Electron issue board, see if anybody else has reported this. This looks like it might relate. Aha! Yep, so Electron has a PR waiting to fix this bug. That means I just need to stick that in my notes here and move on. Okay. Well, that's all my Electron 3 issues that I can tackle right now, at least in the live stream. Of course, I do need to test on Windows and Linux, but I'm going to wait for the other stuff to get finished first. And then the sodium native build is, I just need to ping upstream. Actually, I think that's Matthias's module, so I just need to get him to cut a new build for the new version of Electron, which shouldn't be a problem, but that's just not work that I have to do. So, let's jump over to the sandboxing branch and rebase some of these changes onto it and see if everything's working there. Okay, everything's pushed, I hope. Yep, all right. Let's really chug in here. Michael's asking what the process level sandbox is. It's not new to Electron 3. Hey. Hey. It's not new to Electron 3. It's a feature of Chromium that's been around for a long time, actually. One of the things that Chrome was sort of famous for doing whenever it first came along was adding the process level sandbox. It's just an aspect of the security in depth of the browser. It puts tabs in their own processes, and then uses the operating system mechanics for restricting access to different system resources. An example being, okay, this tab is reddit.com, and it's not supposed to touch the file system, so put it in a process and tell the operating system remove file system access. It's not the only sandbox that gets used, because the JavaScript API is designed to only give certain permissions as well, right? Like there's no file system API that lets you write to any directory you want in JavaScript or in the web APIs. So that is the main line of defense, but there's always the possibility for bugs to come along that allows a web page to break out of the JavaScript sandbox and execute code inside of the process that it's running inside of. So by having an operating system level sandbox on the process that the tab runs in, you can actually improve defense against web pages breaking out and accessing more of the operating system resources, which is a good thing to have. In fact, I think I just saw a GIF on Twitter the other day showing that somebody came up with an exploit that gets out of every sandbox that Chrome has. So even with these mitigations, like the process level sandbox, it's still possible to break out. But of course, that's just the ongoing fight of security. At any rate, Electron originally disabled the process level sandbox because it made it easier to build the kind of applications that Electron was designed to build. Especially because, like, I think they had to do that to get Node.js to run in the same thread as the browser window. That's not something that we need. We don't really need Node.js to run in the window. The design of almost everything that Beaker does, and this is also how Chrome works, is that the web pages run in the tab, and then they pass messages to other processes that have more privileges, and which are sort of managing the security of the environment. So in the case of Beaker, that would be the main process that these web pages communicate with, asking to do things, and then the main process can deny or allow those actions based on the permissions of the tab. So we've basically been relying on the JavaScript sandbox for a while, which is a good form of security, but it's not as in-depth as having the process level sandbox. And the blocker on that has mainly been that Electron's support of the sandbox has been experimental for some time. And they've been improving on it, and the most recent release improved on it even more, which is good. So now I'm making the changes necessary to use it. And it won't be the end of the story, because Electron still has a wider surface area of messages that it sends back and forth between the renderer and the main process, but they're pretty open about this. If you look at their sandbox documentation, you can find information on this. So Electron's just gradually sort of restoring the basic security mechanisms that Chrome has used this whole time, and this is a really big step forward on that, so it's good news. But I have to be kind of careful about deploying it, because I don't want to introduce instability or some kind of loss of a feature that's important. But so far, actually, it's looking pretty good. Let me just open it up and take a look here. I also feel, I'm not totally sure because I don't have a benchmark to prove this, but it feels snappier since I turned on the sandbox, which might be because it's not running Node.js inside of the browser window anymore. You won't see that in the stream because nothing runs fast when the stream's running. At 25% of my CPU is getting eaten by the stream itself, but so okay, things are working as they're expected. And I've done actually most of the work necessary to get the sandbox working. What I need to find out is if the tests pass. So let's give them a go. So Michael, did that explain everything about the process level sandbox? Huh. Interesting. We got another case of tests not moving forward. I rebased this off of the Electron 3 branch. So what we're seeing here must be something new. Something new and specific to the sandbox being enabled. So now we have a little more debugging to do, which is great because I needed good live stream content. So, way to give me some crucial bugs. Glad to hear it, Michael. Glad that all made sense. Okay, well, first of all, let me just double check that the code is running with my update. Yeah, so like on DOM ready, right? That was the change I made recently. That's all there. All right, step one, let's just make a quick pass at the dev tools, make sure there are no errors dumped out in the console that would give us any indicators of what's going on. Nothing there. And what we got in here? Oh. Oh, bummer. Huh. Electron just crashed. Oh, it didn't crash, it succeeded. Huh. That's interesting. Yeah, it didn't crash. The tests suddenly just finished running. Weird. Okay, so something is like delaying them? That's strange. Ha 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 ha. Okay. Well, I didn't notice anything in the console before it decided to actually run the tests. Let's try running the tests again just to see if this is at all related to what I'm clicking around. Because it almost suggests to me that by opening up the dev tools in the shell window, that triggers something that gets the thing running again. So am I out of my mind? Let me just let it sit. Okay. And click events, are they the one? Is it click events getting things going? I think it's actually going to be if I open the dev tools in the shell window. Yeah. Okay, what the heck? That's a good one. Okay, so the tests are stalled unless I open the dev tools in the shell window, and then the tests start running, which means that like there's some kind of condition occurring where my code doesn't run until okay. All right, well, let's start instrumenting it. This might tell us something. An uncaught error in the page. It's got the makings of a clue. None of this got run, so we didn't even get to the test, which is interesting. Also interesting. Okay. What is that uncaught error? What a pain in the butt. Don't you just love it whenever you get an error that looks like this? Uncaught, in promise, undefined. Oh, thanks. Very clear. Alright, well, step one, let's see if that uncaught error occurs whenever I start the browser normally. Because that might be unrelated to whatever's breaking my test. Okay. Nope, no error here. Okay. So normal execution isn't creating an error, which suggests that something about the test execution has an error. This didn't get run, which suggests we may be up in here. Alright, well, let's find out. Let's find out if the pre-test code is actually finishing correctly. Nope, it's not that. Interesting. We're getting hung up on this right here. It could actually be a similar problem to the one I had before, that we're now waiting for DOM ready. Alright, let's take a look at app.isReady. That waits for the shell window ready to run. If that's run, then the code has run. Oh, that uncut promise is probably this. Yeah, that's what that is. Okay, so that was a red herring. That uncut promise error is happening whenever the modal, the intro modal, gets dismissed. It's just laziness on my part. There, could have seen that one coming. Yeah, now a little cautionary tale for myself in the future, not to just let uncut promises show up whenever normal code path executions occur. It's going to misdirect me in future debugging. Okay, so that's not related. For some reason, injected code isn't running unless I open the DevTools. Well, this probably has something to do with the changes to how the shell window is constructed, because I had to change how the shell window is constructed for the sandbox to be enabled. Let's see, do a little exploration in a normal execution outside of the test of the shell window. See if anything stands out to me about a difference in the environment, but I don't think there will be. Of course, one option would be just to not run any of the test code inside of the shell window, just move it into the main tab, which would be possible in this case. It means I have to update a bunch of my tests, because I used that a couple of places, and wouldn't actually answer why this is happening. Sometimes it's nice to just know why the bug is occurring before you just work around it. That archive API does exist, and that works. Huh. This has the definite signs of being some kind of weird quirk of Electron, because the DevTools being open in the show window causes the code to execute. So it's like the JavaScript environment isn't getting a cycle. Like it's, I guess, probably an event loop. No, but see, how would that be the case? It would have to be something wrong with like the execute JavaScript method as defined by Electron, because obviously cycles are being given to the JavaScript that is in the show window. Otherwise, you know, this stuff wouldn't be working whenever I run the test. The show window's code itself wouldn't be running. I guess I could just start moving all that code execution into a different thing. It's such a pain. Well, one thought is, can try the set timeout trick again just to make sure there's not some kind of weird timing thing going on here, which would be definitely smart to make sure of. So let's add a timeout, yet again, putting a sleep in there. Let's put it 3 seconds. This way we can be sure that there's not some kind of readiness issue that we are missing, right? Like maybe, the bug I had earlier was that the page wasn't fully initialized, so trying to run code inside of it was creating problems. Well, could be the same problem here, but just this time in the show window. So a good way to test that is to just stick the set timeout in there. Ah! Did that solve it? C just got hit. C got hit, but we're still not making progress. What's going on here? No, that's because I put that C there. Nah, so that one did. No. I guess a sensible next step would be just to jump into the test driver real quick and see if there's anything obvious. Okay, well, I'm just going to instrument the test driver real fast, see if that reveals anything to us. But if not, I'm out of ideas on this one. I agree, Michael. It's, I mean, it runs totally counter to what I think anybody should be trying to do whenever they're working in code. You should try to understand why you're doing something, but this may just be one where I gotta do that, because this has the indicators of being an Electron bug that's subtle. Something like, you know, execute JavaScript on a web contents fails in some scenarios when sandbox is enabled, or it gets stalled until you open the DevTools, you know, some kind of weird initialization hang up. Yeah. Alright, one other thing to do is try running another test that doesn't immediately use code execution in the shell window. Like this one. This one's a good one. Just the generic browse test. Okay, while this is running, I really gotta use the restroom. So I'll be right back. Sorry about that. Okay, I'm back. So this isn't good, because what we're seeing here is it's not just running code that I inject into the shell window that's test specific. So I use the same mechanism to drive the browser generically, and it also is not running. Oh, it's giving me errors. Show me the error, show me the error. Nah, not a good error. Yeah, so this can't be worked around. So I can't just rewrite my tests. I gotta fix this one. So now I gotta figure out what the cause is. The basic thing that seems to be happening is code injection into the page isn't working. This little bit right here, if I get an active window and call execute JavaScript on its web contents, I should see things happening, and I'm not. So let's jump into the background process, and when my first window is created, I'm just going to set an interval that runs a console.log using this mechanism once every 3 seconds. And if this doesn't work, we know something's up. For an opener, we'll just have a console.log. And let's actually put this inside of an async and a try catch so that we can get logging. So while I'm working on this, should have a good announcement tomorrow. Assuming nothing slows us down. If it's not tomorrow, it should be sometime during the week. New project called Hyperswarm, which is something that Matthias has been working on for a while. It's a new stack of modules for arranging connections between peers. Uses a DHT, a Kademlia-based DHT that Matthias has written. Pretty excited to be getting that integrated. Yeah, okay. So it looks like this execute JavaScript method just doesn't work unless I open the dev tools. So we have definitely landed on an Electron bug if the sandbox is open. Yeah, okay, but look, it looks like it had... Is it that it just doesn't return unless I open the dev tools? Because it almost looked like it had an effect. There's a good way to find out if it's having effects, but we just can't see that. And that's to do something which is effectful in a way that we can see, like that. So let's change the code. Yeah, so Hyperswarm should be pretty cool. It's the DHT is going to have mechanisms for hole punching built into it, which is really pretty sweet because one of the biggest problems with WebRTC is that you have to have a server, which is called a signaling server, that you run somewhere that arranges connections between people. One of the main reasons being that you need hole punching. Hole punching is a process of basically getting a connection through somebody's home firewall, sort of. Specifically what you call the NAT, the network address translator. So what this will do is basically create a... If you're thinking in WebRTC terms, it's like we're creating a signaling server that's distributed, that nobody... No, it doesn't depend on one particular person to run, but it's a giant kind of distributed swarm of hole punchers. Okay, the code's not getting run here. A DHT is a distributed hash table, and it is a way of basically it's a way to have a bunch of people's computers get together and help maintain a database. In our case, that database will be a listing of people's computers that are interested in a DAT. So whenever you're interested in a DAT, what you'll do is you'll say to the DHT, hey, I'm interested in the beakerbrowser.com DAT. It won't actually say that specifically. There's some ways that the key gets modified for security reasons. But that's basically what you're saying to the DHT. And so what you do is you're basically announcing yourself by adding yourself to this database that the DHT maintains, saying, hey, add me to the list of active people interested in connecting and receiving and sending data about beakerbrowser.com. And then other people will be able to be notified that you were added or query the thing to see that you're there. And then try to connect to you. And the DHT will help you do that by helping facilitate the hole punching. And so I'd say it's a database, but it's kind of an ephemeral database. Like the entries will get dropped, if, you know, it's probably all going to be stored in memory. Might use disk eventually. I'm not really sure actually how he implemented that aspect of it, but yeah, so that should be honestly, the reason we decided to go ahead and move forward with it, even though it kind of adds more complexity to the code, is of course we want to have a DHT because that's more decentralized than having us run the tracker server that gets people connected. But the other reason is it's a fresh code stack that has specific facilities for getting people hole punched. So we still got to run some tests, but we're kind of hopeful that we'll just be able to improve the overall connectivity of DAT by going ahead and migrating to this fresher code base that Matthias has built with more experience. And so hopefully that'll be the practical effect of this thing, is that you'll just start to get more connections successfully. There's some interesting challenges to this project still, this Hyperswarm project. The Kademlia DHT has some well-known attack vectors against it that we are going to have to figure out how we want to mitigate. Nothing too serious. It's not like somebody can inject malware or something like that, but what you can do is there's some ways you can kind of disrupt the network, so denial of service attacks. And so if we don't find a way to deal with that, you know, it's always possible that people would be able to attack the network and disrupt people's ability to connect to each other. So we got to think about that. It's an interesting topic, though. Some folks suggested using some crypto puzzles, like proof of work, but I don't think that's going to fly, actually, for a number of reasons. So I'm looking into the issue board to see if there's any indicator as to why these calls would be failing like they are. Specifically, it's with the sandbox executed and execute JavaScript. It's just not doing what it's supposed to. So why would that be? No, that's not what we need. Okay, well, based on what I'm seeing, I feel like it's a pretty good bet that the only way I can make progress here is to create an isolated test case for Electron. So why don't we make this the sort of the last bit of the stream here. Is me making this test case. So I'm going to grab the quick start template. Michael says that his understanding right now is that you have to quickly talk to a centralized DAT server before you can discover IPs in the swarm. It sounds like Hyperswarm might remedy that. That's accurate, yeah. You have to have some bootstrap to the network some way to find other peers. And we obviously don't want to have to run that for everybody, both because we can't afford it, but also because that's not the point. It's supposed to be common infrastructure. So switching to DHT is a way to kind of move the network off of services that we run. We'll still have to run bootstraps, but you can have bootstraps be run by lots of people. So ideally, the bootstraps will be interchangeable. But it gets more complicated on account of the security issues I mentioned. And one of the ways to deal with the security issues is to set up a system where you can only have DHT nodes that are approved by a central authority. So then you have sort of like an ICANN scenario, which is kind of a compromise that you got to consider in the realm of possible compromises on this kind of stuff, but we'll see. It turns it into a people problem, which sometimes that's the way to do things, is to solve things organizationally. Okay, got focus here. Sandbox, execute JavaScript. So I'm basically pulling down the Electron quick start template here and using it to put together a test case for this bug I'm seeing. And if I can reproduce it here, then I can file an issue with Electron and we'll be another step closer to getting all these tests passing. Since we're kind of in the last home stretch of the stream, if anybody has any questions they've been wanting to ask about Beaker or DAT or anything else, now's a good time. Say we maybe got probably about 10 more minutes on the stream, maybe 20 most. Okay. Yeah, I'm hopeful that the Hyperswarm will really set us on a path of more, you know, better connectivity overall. Because it's definitely one of the biggest challenges we have. It's not quite as good as I want it to be, and that's not surprising. Getting peer-to-peer connections to work is a shockingly difficult thing to do. You would think that the web would be good at that, of all things, rather the internet, but nope. Nope, not good at it. Arguably, that's one of the reasons that cloud services have been so entrenched. Is that because it's very hard to accept connections from a home computer. So you end up having to use cloud services which reliably accept the connections, and that just exacerbates the problem of relying on the cloud more. Seems to be working. Which isn't good. That means this one's going to be tricky. Sandbox is definitely enabled because couldn't all this code that is used by default to access outside of sandbox stuff is failing. Alright, let's see. I'm just trying to reconstruct all the conditions of my environment and my usage to match. Trying to find what is triggering this particular issue. So I'm adding in a preload script and sandboxing. Yeah. Yeah, I always use the E3. Michael's pointing out how I use 3E3 for intervals as opposed to the full 1,000. Just makes it a little easier to read because the E3 has basically become a shorthand for me for, you know, a second. Whenever you're putting in milliseconds. Okay. Fingers crossed that I've reconstructed the conditions. Fingers crossed. No. It's running. I don't know on this one. Guess I'm going to have to keep debugging this one offline because I have no idea what could be possibly causing this bug. Something. I guess probably what I'll do next is start taking code out of Beaker. Out of the preload, like I'll get rid of the preload. And, yeah. Weird bug. I just got to figure out what the conditions are that would lead to it. Huh. Alright. Well, I think I'm going to wrap it up. This was a long stream, 1 hour 40, longer than usual. So thanks everybody for coming on as usual. And you know where to find me online. Find me on Twitter, find me on IRC, send me an email, whatever medium you prefer. Keep an eye out for the announcement for Hyperswarm this week. And I think that about wraps it up. So y'all have a good rest of your weekend, and I'll see you online.